Hi guys, it's John here from Hex Crypto, and today I'm going to be showing you how to set up your own ScPrime miner with a Raspberry Pi. So SCP is a cryptocurrency which you can mine by sharing hard disk space with other people on the internet. So people will pay to have their storage in a decentralized setup, and ScPrime is one of those companies which allow you to do that. So you can see here I've already got some bits and pieces here to set mine up. If you don't have the time to set one up yourself, you can actually purchase one from their website. So we can see here on the site the XA miner. So these are pre-built systems which have lots of space inside which you can purchase, and it's basically a plug and play version of what we're going to create today. But the problem with this, as nice as they are, is that for a start, they're not available, and secondly, if they are available and when they are available, they're extremely expensive. So we have a look down here, we can see the various different models here. So this one here starts at $1,500. So it's not cheap, that's for 16 terabytes of disk space. And you do have to get this nice fancy custom built miner, which has everything you need to get started with. But $1,500 is a lot of money. That is what, over £1,130. So that's why I think it's probably better to build your own if you can. Now, SCP hasn't quite launched yet. They are in beta still, and they hope to launch properly or fully in January or February next year. So potentially by the time you're watching this, they have already launched, but at the moment they haven't, they're still in beta. So it's probably a good idea to set yours up now if you wanted to actually get involved in this. So all the resources and documentation on the site are available obviously, but I'll just go through briefly what you need to set one of these up. So the minimum requirements for a ScPrime node are a Raspberry Pi 4, if you're going to use a Raspberry Pi that is. You can obviously just install this on a server running Linux or Windows if you want. I do actually already have one set up running Windows. It's not as good as the Linux version in my opinion. I'm a Windows person myself, but even I have to admit that the Windows GUI version is pretty horrible. But anyway, we're going to be setting up on a Raspberry Pi 4. That is the minimum requirement for this to run with 4 gigs of RAM. So it's the cheapest Raspberry Pi 4 you can get basically. And you do also need to have at least 500 gigs of free space on the drive that you're going to share. So you can see here I've actually gone for a 5 terabyte drive for mine, because I want to make sure I do get as much space as I can in the cheapest way I can as well. So this was the cheapest drive I could find. But basically, going back to the requirements, you do actually need a few things as well. So like I say, you need 500 gigs of storage minimum, and then you need to price your storage accordingly. So you can set the amount that you want to charge for your storage, but you do also have to offer some collateral. So the collateral is basically if your node fails to deliver, then you may end up losing some of your money to pay for the fact that the client's data is not available. So just bear that in mind. You do need to have a decent, fast internet connection with a decent uptime as well, because you will get penalized if you do start going offline all the time and your node is going up and down. So just bear that in mind, but we will go through all of this as the video progresses. So I'd just like to say, please do click the subscribe button if you enjoy this sort of content, and do click on the like button as well, that really helps out. And I have put time codes in the description. If you do want to skip forward anywhere in this video, then that will be available for you to do so. Right, I will just go through the bits and pieces I've bought here to get the node up and running. This is the sort of minimum specs I can recommend personally for setting up a node yourself. The reason will come clear as to why I've gone for 5 terabytes and not 500 gigs. It's basically because you get paid more money for having the storage available than if you have a smaller amount. But anyway, we'll go through that as the video progresses. So I've put Amazon affiliate links to all of this. This is all from Amazon, and I've put links down to each part in the description. And I'll just go through the price of each of these so that you can sort of get an idea as to how much this is going to cost. So the Raspberry Pi 4 itself costs £64.80. So that's quite a big expenditure. And obviously the 5 terabyte hard drive as well. This was $89.99. Now I do already have one of these set up running on my other node that I have running, and it's been fine so far. The reason I went for a 2.5-inch drive is because I didn't want to keep using lots of different power sockets for the external drives. I want this all just powered from the Pi itself, and obviously from the power supply, which is here. So the power supply I've bought is £8.79, and again this is one that comes with a switch, which is always quite handy, and it is a 3000 milliamp hour one, as you can see from here. So the case I've gone for is a slightly different one to my previous node that I set up for the Mysterium network. Now this one actually comes with a fan. This was £5.99, And the reason I went for a fan is because I just want to ensure that this node keeps up and running and it doesn't have any troubles with any heat when it's in the summer. Because I know that this will probably utilize more CPU than a Mysterium node, I thought I'd splash out a couple more pounds on a case which has a fan built into it. I also thought this one looked quite cool, to be honest. It looks like a little mini XA miner almost. Well, not really, but I thought it's a good, nice sort of style anyway for it. So that's the case I've gone for here. Now I've gone for a 128 gig MicroSD card here as well, because they recommend to have at least 100 gigabytes free on your system drive for the metadata. So that's all just recommended on the site itself. This was only £10.98 for a reasonable brand, Kingston, because you want to make sure it's reliable at the end of the day. So the total cost of all of this so far is £180.55, which is just under $240 at the moment. So compare that to the $1,500, you can see that you can actually get up and running with a node a lot cheaper if you just do it yourself. So I'm going to pop this together now, and we will get the OS installed, and then we'll install the ScPrime software as well on top, and we will then get set up and get our storage shared. So we can see here we've got some little heat sinks with this case, which is nice. So I'm just sticking these on the chips. You just peel back, obviously, and line them up as best you can. Right, so that is our XA miner all configured, or our sort of cheapo version of it anyway, at least. So now all we need to do is actually get the microSD card flashed with an image. So I'm going to get this out of the case if I can, and we're going to go over to the PC and get the right software installed. So you'll just need some sort of microSD card reader to actually do the imaging. I'm just going to use this cheapo one I have here, get that in, and then we'll go over to the computer now and get the image flashed. Right, so over here on the PC, what we're going to do is go to the Raspberry Pi Quick Start Guide. We're going to download, or click on the link to download the Raspberry Pi software here. It's just the standard Raspberry Pi OS. So we're going to get that downloaded for Windows. I do actually already have this installed, but I'm going to go through it anyway. So we're going to get this running. Okay, with the imager loaded, we're going to just do Choose OS. We're going to click Other General Purpose OS. We're then going to go onto Ubuntu here. We're going to find the Ubuntu Server 64-bit version. So this is for ARM, as you can see. So we're going to click on here. Now we're going to choose our storage, and we're going to select our 128 gig drive, and just double check that everything is correct. We can see USB drive E, and this is completely empty, so we're going to select that. USB drive mounted as E, and then click Write. All existing data will be erased, that's fine. Click on Yes. And this is now going to just image the Raspberry Pi with Ubuntu server. So once we've done this, we can basically get ScPrime installed, and then we can start configuring it. Right, so our microSD has finished imaging now, so we can click Continue and remove that from the computer. And we can now pop this into our Pi. There you go. So I've got my disk drive here. I'm going to just have this on top, so it's a nice little compact system. And I'm just going to power this up now. I'm going to stick an Ethernet cable in the back of this. I don't have an HDMI cable to connect up to here, so I'm going to get the IP address from my router. I'll just show you how I'm doing that, but obviously you'll have to look at your own router, or if you have got a little mini or micro HDMI cable, you can plug it in and get the IP address that way. Okay, so like I said, if you haven't got a HDMI adapter for your Raspberry Pi, there is a link in the description to one if you did want one. You can get your IP address from your router, of course. So I found my device here, it's just called Ubuntu. So this is the IP address I'm going to use, and I can set this as a static address as well in my router, so it will always be the same. But I'm going to use this IP address here to connect to it via Putty, and then we'll be able to install the ScPrime software. Okay, so in Putty, we're going to create a session with the IP address that we've just found. I've just saved this with a good name so I can remember what exactly this is. And I'm just going to click on Open. It'll pop up and say that the key is not cached. Just click on Yes. Okay, and what we're going to log in as is Ubuntu. And the password is Ubuntu. And we are now in. It's now going to ask us to create a new password. So we're going to set our new password up, and it will now pop out because it's logged us off. So we now need to log back in. So in our list of servers here, just going to load this up, double clicking on it there. So I'm going to log in as Ubuntu now again with our new password. So one of the first things we want to do is set up our hard drive. Now, I'm not a massive fan of doing this on Linux, so do bear with me. I'm just going to copy a guide that I found on the internet. But basically we need to set it up with a partition. We need to format it and mount it, and then set it to auto mount on boot. So it sounds a bit scary. It's not too bad, but it is just a bit fiddly. So we're going to go through that now. So I'm just going to go into sudo here, so I don't have to keep typing sudo in front of every command. And now we're in as root, as you can see by the little hashtag here. So I'm just going to do fdisk -l. This just lists what disks are attached to the system. So we can see all the disks that are attached. That's the MicroSD card. Here is our 4.5 terabyte disk. So we know now that the disk is under dev/SDA. So we're just going to do a gdisk on this now. So gdisk/dev/SDA. So now we're in the program called gdisk. It's now asking us for a command. So you can have a look at the commands here if you wish. But what we're going to do is just delete any existing partitions, and then we're going to create some new ones. I'm going to press on delete and delete again. And we can see here we've done it twice. There's no other partitions, so it deleted the only one that existed. And now we're going to write that to the disk by doing a W, and then press yes to confirm. Okay, so now we're going to create the new GPT partition by typing gdisk/dev/SDA again, because we want to go back into the gdisk application, and we're going to type n. So if I just bring up the help again, you can see n is doing a new partition, so we're going to add a new one. Type in number 1, we want it to be the first partition number, and then just keep pressing return to agree to all these bits and pieces. We're going to write that to the disk and press yes again to confirm. And we've now got our new partition set up. So if we do an fdisk -l again, we can see here our disk is still there. It's still looking okay, so we're now going to give it a format. So when we're formatting, we want to format the partition itself and not the disk. So be careful with the next command, because we're going to put a little 1 after the SDA, because we want to format the first partition that we just created. So we're going to do mkfs, and we're going to do it in ext4 format. So that's the disk type we're going to create. And we're going to do dev/SDA1. So don't forget that 1, because we're going to format the first partition that we just created. I'm going to click on yes to continue. Okay, and once that's done, we now need to get the drive to mount itself every time the system turns on. So if there's a power cut or anything, we want the disk to reattach itself to the system once the power comes back on. So we're going to get the UID of the disk, or the UUID. So we're going to type in blkid. We can see here, this is the drive we just created, or the partition, sorry. So SDA1, and the UUID is this number here. So just get that into your clipboard like that. You just need to select in Putty, and that will copy it into your clipboard. Okay, and now we have this number. We need to tell the system to mount this every time the system boots up. So to do that, we need to get into something called fstab. Now there's many different editors out there. There's Nano, there's Vim, there's all sorts of different ones. I normally use Vim myself, which is basically typing vi, and then we're going to go to /etc/fstab. Okay, so we can see here currently what is in the fstab. Now in vi, you need to press I on your keyboard, and you can see we're going to insert mode. So we're going to create a new line here. Go to the end of this one and just create a new line. I'm going to type in UUID. In fact, we can let's put in a little label here so we can actually see what we're doing. Although the color of this isn't very good, I'm going to call this ScPrime storage. You may not be able to see that, but it does actually say ScPrime storage. And I've now lost my UUID out of the clipboard, so let me come back out of here. Basically, whenever you select anything in Putty, it will become part of the clipboard. So I need to select that again. I'm going to go back into FS tab, press I to go into insert mode, go to the end of this line, just put in a few spaces here. I won't bother putting a note as you can't see it with the color coding I've currently got. So UUID equals, and then right click your mouse, and that will paste in the UUID. Put a space, and then we're going to put in where we're going to mount it to. So we're going to go to mount, MNT, slash, and then what we want to call it. So I'm going to call this ScPrime. That seems to make sense to me. And we're going to tell it it's ext4, as that's how we formatted it. And I'm just going to leave everything out as defaults, 0 and 0. So now when we reboot the system, we will be able to go to this mount point here, and that will be the new partition that we've created. So to save this, we're in insert mode still here. We're going to press escape. And now we're going to do a colon, as you can see down here at the bottom. Then we're going to type write and quit, which is W and Q. So we're going to write the file, and then we're going to quit out. Okay, it's as simple as that, hopefully. So let's give it a reboot. And when it comes back up, we'll reconnect via Putty and just see if that new mount point exists. Okay, the Pi is rebooted, so we're just going to log in now. And we're going to do an fdisk -L. We'll get into sudo first, fdisk -L. So we can see our disk is here. So now if we go to cd/mount, we can see ScPrime comes up straight away. So we're now in the ScPrime mount point for our disk that we just formatted. So we can have a look at the file system, or files if there are any existing. There shouldn't be. So ls, which is list, and then list all and hidden. And we can see there's nothing really on here at the moment, but we are in the right place, and that did mount itself automatically. So we're happy now that our 5 terabyte disk is now mounted, and it will keep on mounting every time we reboot the system. Right, so now we can actually get around to installing ScPrime. So to do that, we're going to install unzip first. As we are already as the sudo user, we can just do an apt install unzip. This is just installing the unzip application, that we can actually unzip the image when we've downloaded it from the website. Okay, so we've now got that installed. So next up, we're going to create some directories for us to store the metadata and also the storage. Now, because I want to use all the available storage on the external disk, I'm going to set the metadata to be stored on the SD card itself, or the microSD card. That's why I bought the 128 gig size. Like I said, they recommend keep at least 100 gigs free. There's no chance this system itself will use more than 28 gigs, so we should be good with that 100 gigs on the microSD card. Okay, so we're in the root of our system now. This is on the internal microSD card. If we do an ls just to see what's here, we can see these folders that exist currently already. Now I'm going to put the metadata on the root of the drive here. You can put it somewhere else if you wanted to, it doesn't really matter too much, but I'm going to stick it on the system here. Just have a look what we've got. So yeah, there's no reason why it can't go here, so I'm going to just create a folder. So I'm going to do, let's clear this out of the way, I'm going to do mkdir, which is make directory, because we're making a folder, and we're just going to call it metadata. Okay, so if we do an ls to list what's here now, we can see there's now a folder called metadata. So next up, we want to create a folder for the software itself. So again, I'm just going to create this in the root just for ease. So mkdir ScPrime. And now we're going to cd to that folder, cd change directory to ScPrime. And you can see here we're now in the ScPrime folder. So next up, we're going to download the software. Now I'll stick this link in the description, but always check to see what the latest version is because they do update it quite frequently. But you can basically just paste this in. It's a wget command here, as you can see, and this will download the current latest version. Well, it will download the version that's selected, obviously, but always check on the site in the link I put in the description to make sure you download the latest one. So we've downloaded that, it's nice and quick, and all we need to do now is unzip it. Like you would in Windows, you need to unzip zip files, and we know that we're in the right location. If we do a list here, we can see that that zip file exists. So we're now going to do unzip, which is what we installed earlier, and we can either start typing this in and press tab, we can double click this and then right click here to paste it in. There's many ways you can obviously get this to fill out without typing the whole thing in, but either way you want to just unzip it. Okay, and so we've unzipped the folder. Let's have another look. So we're going to do a list, and we can see here in this sort of violet color that the folder is here. We can delete this zip file if you want to save on space. Just do an RM, which is remove. I'm going to double click on here, right click to paste, and then if we do another list, you can see that's now gone. So in the ScPrime folder, we've now got a folder called ScPrime version 1.60. So we're going to change directory CD to here. Again, you can either start typing and press tab to fill in the rest, or you can double click and paste it in, but we're now in that directory. And in here, there's actually an executable we can run to actually get the software running and syncing to the blockchain. Okay, I'm just going to clear the screen, and we're now going to run the command that will basically start up the software as a daemon and start syncing the blockchain. So to do that, you just type in /SPD and then a -d for the directory, because we're going to specify the directory we want the metadata to be in. Now we stored it in the root of the system, so we're going to do /metadata. Now if I just press tab here, that will auto fill for me. I don't want that slash on the end though, because we're specifying a folder or the folder itself. So do a space, and then we're going to do -m gctwh space ampersand, and this is going to start the daemon running and get it syncing to the blockchain. So we can see here it's going through, it's loading, it's doing bits and pieces, and it's saying the API is now available. Give it some time because it's going to start the synchronization now, and it will take some time before it's saying it's completed before you can continue. Now if you're a bit sad like me and you want to just check its progress or to see what the system's doing in the background, you can open up a new Putty window and log into your system again and just type the word top, and top basically will show you the current load on your system. So we can see here at the top, or even on this top line here, the SPD, the thing that we've just run here, the daemon, is currently using around 17 to 30% of the CPU. So we know it's working away and busy doing something. So this will take some time, like I said. So you can sit, if you're really sad, and watch this until it completes, until the confirmation message is here. Or I would advise you probably just go and make a cup of tea or something while this is happening, because when I did it on my Windows system, it did take quite a long time. Right, while this is running, I'm going to just go through the Duck DNS setup. So basically, we want to ensure that our IP address or our system is always accessible. Now, most people at home don't have a static external IP address for their internet connection. So you're going to need to have some way of telling the ScPrime servers what your current IP address is whenever it changes. So I use a system called Duck DNS. It's completely free and it does everything I need it to do. And it's quite simple to set up, so we're just going to go through that now whilst our node is initializing in the background. So basically you can sign in and create your own subdomain to be something.duckdns.org. Then your Linux system or whatever, it does work on Windows as well, will update the IP whenever it changes, and you'll be able to use this name to always access your IP wherever it is and whenever it changes. So let's create one. I'm going to call it Hex Crypto, and we're going to click Add Domain. And we're going to click on Install. We're going to click Linux cron here because we're running Linux. and we're going to choose the domain that we want to update. So we've just added the hex crypto on here. So once we've done that, it's going to just tell you exactly how to set this up. It gives you all the details, everything you need to do to get this up and running. So we're going to just run through that now. I'll just move this across, and you can see this is still going in the background, so we'll leave that there. In fact, I'll minimize that. Okay, so it's saying first to check if we have any cron tab running. So we're going to do ps-ef and pipe, which is to the left of the Z key on the UK layout keyboard. We're going to do grep and then cron. And we can see here that it does exist. So we know that cron is installed and we're all good to go. Cron is basically a way to create jobs on your system which run at certain times that you specify. Right, so we're happy we've got everything we need. So now we need to make a folder for Duck DNS. Now this has to go in your root folder. So we're going to go to cd/root. And we're now in the root folder. We can have a look, list what's in here, not much. But we're going to make the Duck DNS folder in here, mkdir Duck DNS. Have a look, it's in there. Okay, so we're now going to cd change directory to Duck DNS, and we're now in the Duck DNS folder. So now we're going to make a script which is going to do the automatic updating of our IP address to the Duck DNS servers. So we're going to type vi and then duck.sh, or duck.sh, sorry. And this is going to create the script for us. So again, they have the exact code that you need to paste in here on the site when you've logged into it. So yours will be different to this. Mine is this currently. But I'm going to paste this into my file here. We're going to do I for insert, as you can see at the bottom. Right click, and that pastes in like that. So when you're happy, press escape, do a colon, and then write and quit. So we've got our file in there now. We just need to set the permissions on it properly. So let's see what it is currently. ls minus lah. These are the current permissions. I'm not going to go into this completely, read, write, read, read, but we're just going to do a chmod. So change the modified permissions to 700 on duck.sh. And we'll just do another ls minus lah, and we'll see here that we've now got read, write, and execute on the file. So let's just test it out. We can do a /ducksh, duck.sh, sorry. Press return, and we can see here it's updated okay. It should have created a log file, so let's just have a look. There is indeed a log file. So to view the log file, there's many ways you can do it. I'm going to use something called less, and just paste this in here, less.log, and we can see a very informative OK in the log file. Press Q to come back out of there. So the update went through OK, which is good to see. So let's just check to see if our node is finished. It's still going in the background here. So at least we now have our Duck DNS setup okay. We should be able to ping our address. Let's give that a try just for fun. So ping hex crypto.duckdns.org, and you can see we've got a response and it is responding, so we've got our own name here now. So what we want to make sure now is that this updates automatically all the time. So we're going to go into what's called cron tab. This is like the Windows task scheduler basically. So go to cron tab -E, and you'll be presented with the following. So we're going to go to insert, because we're going to insert a new line here. Go down to the bottom, put in a brand new line here. So again, this is what you can copy and paste from the Duck DNS site here. So I'm just going to copy this in exactly as it is and right click to paste it. Now I'm going to press escape, colon, write and quit. So we've now got if we go back in, every 5 minutes, like I say, for the rest of the time, it's going to run that script. So when our IP does update, within 5 minutes, our DNS name, or our Duck DNS name with the IP will also update as well. Just going to do a colon, Q for quit. And we're now configured to auto-update our IP Right, so as this is still going, it's still downloading or sorting out the metadata in the background. As you can see, the load is still maxed out here. What I'm going to do is actually go through the setup for the collateral and how we can work out how much collateral we actually need. So basically, shortly we'll be setting up the wallet and the storage folder and then setting the prices that we're going to charge people to use our storage. So you can set, these are sort of recommended minimums for the guidelines for a new node. So you can charge 10 SCP per terabyte per month. The collateral will be 12.5 SCP per terabyte per month. And then the max collateral will be 50 SCP per contract. So that's the whole contract worth. And the collateral budget is just 2 KS, which is the set total collateral available. And the max duration of a contract is going to be 13 weeks. So these are all the things we're going to set up. So we need to know how much collateral we need now. So we've got 5 terabytes. So if we bring up the calculator here, and it says if you're going to be pricing at 10 SCP per terabyte, you need 60 SCP per terabyte for collateral. So we're going to do 5 times 60, which is 300. So we need 300 SCP as collateral for our 5 terabyte drive. Now, if you're going to charge more for your storage space, you think it's worth more than mine, then you can charge 15 SCP or 20. You can charge as much as you want really, but obviously the higher you charge, the less likely people are to use it. So I'm going to stick with the 10 SCP per month, and we're going to need 300 SCP to do so. So SCP is currently doing pretty well, as you can see here. Now it's gone up pretty much twice the price of when I bought it for my initial node, which was around October, September time. It was around 35 cents per SCP, but it's gone up to nearly $1 per SCP now. So I'm going to get in while I still can, and I'm going to use SouthXchange to purchase. I've put a link down below if you want to sign up through there. You can also use Probit Global to buy SCP, but I'm going to use SouthXchange as that's what I used before. Right, so I've transferred across 300 USDT to SouthXchange, and I'm now going to go into the markets bit here, and we're just going to search for stable coins. We're going to find SCP USDT in the list because that's what we want to trade for. So we want 300 SCP, which is going to cost us 297 USDT. So rather than doing that, I'm going to select USDT and just use the whole amount, and then we've got a bit extra on top. So I'm going to buy 300 with USDT at a price of 99 cents, and we'll receive 301 SCP at the end of it. So buy SCP with USDT. You're about to buy 300 USDT. Do you want to continue? There's a bit of a fee there. That's about what, just under $1 fee. And click yes. So if we click on our wallets now, we can see we've now got our SCP in our wallet, 301. So this is going to be ready to transfer across to our Raspberry Pi for the collateral. So we'll just go through some of the other bits and pieces on here whilst we're waiting. So one of the questions, do I get my collateral back? Yes, upon completion of the storage contract, the risked SCP is returned to your provider's wallet along with the rent payment for the contract. The collateral is only lost if you as a provider fail to hold up your end of the contract. So things to remember, you do not need to cover the collateral for your entire capacity right away, and you get collateral back at the end of the storage contract, assuming your provider stayed online for the duration of the contract. So the reason I've purchased the full amount of collateral is because obviously the price of SCP is increasing. Now you can see here over the last year it's gone up quite a bit. So I'm going to just get it all in now, and then I can sit back and just forget about it and just leave it running in the background and not have to worry about the fact that the collateral is either not going to be enough or something in the future. So I can just quite happily sit there and let the collateral do its own thing and work itself out without me having to think about it. Right, so it's the next morning and the startup has finished. So we've finished getting all our metadata and sorting it all out. And we can see it's taken a long time here. It's taken 26,934 seconds, which if you divide by 60 a couple of times, gives you 7.48 hours. So nearly 7.5 hours it's taken to actually do that metadata setup. So if you are going to do this, advisable that you do it just before you go to bed, and then when you wake up in the morning, it will be complete. So we can carry on with the video now at least, but I just thought I'd let you know it does take a very long time indeed. Okay, so we have our metadata set up and ready and waiting. So now what we're going to want to do is create our wallet. So the wallet is where we're going to be storing our collateral and where we will get paid for storage use. So I already have a node, but if you do have a node set up already, it is recommended to have a separate wallet for each node. So if you're going to create multiple nodes, then create a new wallet for each one. I'm going to set one up here for this one. And to do that, it's quite simple. We're logged into our node. So we need to go to our directory where ScPrime is. And we stuck it in the root here. So we're in ScPrime. And if we have a look, we go into the folder inside this. Okay, so in here, the applications that we need, or the daemons, or whatever you want to call them. But what we're going to want to do is do an SPC wallet init, so to initialize the wallet. So we're going to run this, so it's a / to run the SPC command, wallet init, which means initialize. We're going to press return here. And you're going to see your recovery seed here. So you need to make sure you write down the seed and also the encrypted wallet password. So whether you write it on a piece of paper, copy and paste it, email it to yourself, store it somewhere very safe if you can. I'm going to just select it here and then just store it somewhere secure. Right, so now we've got our wallet initialized. We want to unlock it so that we can actually use it. So the command for this is /spc wallet unlock. It's now going to ask you for your wallet password. This is the password that was under your recovery seed. So I can select mine here as it's still on the screen. So I'm going to select it all and just right click. And the wallet is now unlocked. Right, so if we want to have a look at our wallet, we can just type /spc wallet. And we can see all the details here about it. So the balance and everything else. Now we want to transfer our collateral into this wallet from our SouthXchange account. Right, so I'm logged back into my SouthXchange account here. I want to send my SCP that I bought the other day into my SCP node here. So I've still got my 301 here, so I'm going to go to withdraw. Now the destination is obviously our wallet address here. So if you wanted to, you could do SPC wallet address and get your wallet address here. And then just paste that into the destination. Now the minimum you can send is 0.01 SCP. So I do advise as a test, you just send a small amount first just to make sure everything's okay. This is what I always do. You will obviously have to pay a fee to do that, but I'm going to send, let's try sending 10 SCP across. We're going to tick I pay the fees because there's no one else going to pay it for us. Put in our authenticator code. Okay, so always just double check the start few digits and the ends few digits are correct at the address you're sending to. We're going to send 10. We're going to pay 0.001 SCP as a fee, and then just click withdraw. It's going to ask you to confirm. I'm going to press yes. Now we're going to have to go to our email and just confirm the transaction. So we're going to just click on this link to confirm it, and the withdrawal has been initiated. So now we're just going to wait, and we can just keep on typing SPC wallet and just wait for the confirmed balance to increase. Right, so I'm just refreshing the wallet every so often. We can see that the height of the wallet was increasing each time as well, so it's now finished getting to the desired height, and we can now see there's also 10 SCP that's been unconfirmed. So that means it's sat there waiting somewhere. So we'll just give it a few more moments and it should appear in the confirmed balance. Right, so it's been about 10 minutes or so since we did the transfer, and it is now in our confirmed balance. So we know that we're safe to continue and transfer the rest of the balance across. So again, we're going to get our SPC wallet address. I'm going to copy this in. I'm going to double check the start, F94, and the end, D31. You can see it's a different address from last time. It has created a brand new address for us. That doesn't matter. You can still send to the old address if you wanted to, but I'm going to send to this new address. So I'm going to transfer my remaining SCP here. I'm going to put in our two-factor authentication code. So again, double check the last three and first three. So D31, F94. I'm going to tick the box. We're going to pay the fees. And we're going to go to withdraw. You're about to withdraw, just to confirm it all. F94, D31, yes. Okay, so it's not quite enough with the fees being paid, so I'm going to just go for 291 here and go to withdraw again. Gonna have to update this. Go to withdraw, 231 F94, and click yes. Going to confirm it via email again, and the withdrawal has been initiated. So now we can just simply run SPC wallet, and we'll wait for the unconfirmed balance to appear, and then we'll wait for it to appear in the confirmed balance. So again, that's going to take about 10 minutes or so in total. Could be faster, could be a bit slower, depends on how busy the network is. So I'll come back to once it's done. So here we are, it is currently in the unconfirmed delta, so in a few moments it should be in our confirmed balance. Right, and our confirmed balance is now fully registered and we're ready to go. Right, so the next step we want to do is actually add our storage folder into the system so that it knows what we're sharing. So if you remember, we created the mount point. Let's clear this out of the way. And it was called ScPrime. So we know that in the ScPrime folder, we have nothing in there yet. If we just do a check on the disks here, we can see we've got 4.6 terabytes mounted to that mount point there. So what we want to do to tell ScPrime where our folder is going to be, we're going to do a /spc. We're going to go back into the SPC folder. So that was cd/ScPrime, because this is where our executables are being kept. So here are our applications here. And what we're going to do is do an SPC host folder add. We're going to tell it where the folder is. So we went to mount/ScPrime. As you remember, it was up here, mount/ScPrime. Then we're going to tell it how many gigabytes it's got to use. Now this is a 5 terabyte disk, so we've got 5,000 gigabytes. So I'm going to type in 5,000 GB. Now don't forget, if you're storing your metadata in the same drive or on the same drive as this, you cannot use the full amount because it will get corrupted once it fills up. So if you did put your metadata in your external disk, then just set this to say 4.9 terabytes, so 4,900 gigabytes, and then you've got the 100 gig free for the metadata. But yeah, just remember that. That's why I set mine to be on the root of the host itself. So I'm going to just press return here, and that folder has now been added. So what we're now going to do is follow the guide again on setting up our prices that we're going to set up our node. So there is the guidelines here, which we can open up as well. So again, you can follow these guidelines and just have a read through and set whatever you want to set. I'm going to just follow the guide and set them up as follows. So we're going to set our minimum price for storage as 10. We're going to set the collateral to 12.5. We're going to put the max collateral to 50. The collateral budget is 2KS, and then the max duration is 13W, which is 13 weeks. After we've done that, we can then announce the host, but we'll go through the configuration first. So I'm literally just going to copy and paste those commands into the Putty window here. So SPC host config, min storage price is 10 SCP. So if you get this message pop up, you can ignore this. You don't need the renter module, so we'll just continue anyway. I did check on the Discord to ensure that was the case, and it is. You can just safely ignore that message. So we're going to carry on now, and we're going to pop in the collateral, which is going to be 12.5. Again, set these to what you want, but don't forget, if you set them too high or too low, you may have issues. Set the max collateral, the collateral budget, and then the max duration of the contracts that can be on your device. So 13 weeks is the maximum we're going to set. Right, so now we are going to announce our node to the network. So to do that, we're going to do an announce command. So it's quite simple. It's /spc host announce. And then we're going to put in the dynamic DNS name that we created earlier. So it was hexcrypto.duckdns.org. And then we're going to put in the port number, which is 4282. Right, so once you're happy, you can just hit return. And you can see it's been submitted to the network, and the host has also been configured to accept contracts. So if you're not quite ready yet, you want to move your node around, you can run this command to set accepting contracts to false, and then you can get your node in the right location where you're going to leave it, and then set it to true when you turn it back on. So I'm just going to do that now because I am going to get mine moved. So I'm going to set it to false, and that's fine. It doesn't. Let's do it with a forward slash and a dot. So we can see here the host settings are updated. So I'm just going to move mine to the location it's going to be in before I actually re-enable the contracts, but we should see it in the browser now. So if you go to the main ScPrime website, we can go to storage network status, and we can see here a list of all of the active nodes on the network. And once the list is loaded, we'll see ours appear on the list. Don't forget, it will take a few minutes to actually show up. So once it has, we'll come back to the browser and we'll go from there. But to shut down our node, to move it safely, I'm just going to type shutdown in the window here. And we'll let the system shut down. Right, so next up we're going to create a startup script to actually start the service once the node has been powered down and powered back on again. So to do that, we're going to do a few things. First, we're going to create a Sym link, which is a symbolic link to this folder. This is in case we ever update our version number here to say 1.61 or 1.62. We're going to create a symbolic link to this folder so that we don't have to worry too much about the name of the version itself. Now you could of course just completely rename this folder and call it something more generic, but creating a Sym link is an easy way to do it without actually renaming things that we've already set up. So what we're going to type is ln, which is link, -s, and then we're going to put in the path, the original path that is, so we're doing ScPrime -ScPrime, and then we're going to put a space and then where we want to link it to. So we're going to link it to /mount/ let's call it, you can call it anything you like, we're going to call it ScPrime current version. Press return, and we should now see, if we go to mount, to a list, we can see we've got a link now to our ScPrime current version, which points to the correct folder in /ScPrime. So now we can always use this to get straight to our ScPrime current version. Right, so just to clean up a bit, what we want to do is get ScPrime to start up and also unlock the wallet for us when it reboots. So if the node ever goes down, or if you need to update it and restart, everything will start up automatically as it would in Windows as a Windows service. We're going to do that on our Raspberry Pi here. So first up, we're going to create the service itself. So to do that, we're going to go into the following location: cd etc systemd /system. We're going to edit a file called scp-daemon.service. So you can copy and paste my script here that I've put in. This is the setup. So basically what it's saying here is, after the network has started up on the box, run our startup script, which is going to be here, and the install bit here is just leave that as default target. Again, you can just copy and paste this from the description, but that's going to be our service startup. So let's quit out of here, :q, just to quit out. So let's go to our area where we're going to put the script, which is cd user local bin. And in here, there's nothing here at the moment, we're going to create a script. Let's call it scp startup.sh. Okay, and again, you can copy and paste this from the description, but obviously with your own details. And your script will basically end up looking something like this. So we've just setting some variables here. We're getting the password, which we're going to set next, and then we're going to run SPD, and then we're going to unlock the wallet. So again, copy and paste this from the description. Do note that these bits here are the backtick. They're not single quotes. They are the backtick symbol, which on a British keyboard is to the left of the number 1 key. So we're now going to create a file here with our wallet seed in. So let's just copy this location. We're just going to write and quit this file. Then we're going to do vi and this place for our unlock seed. So in here, press I and paste your wallet seed here. Once you've pasted it in, right quit, and we've got all the files we need. So we've got the daemon service, we've got the startup script, and we've got our seed in this file. So we just need to set some permissions now. So chmod 744 user local bin SCP Startup. And then we're going to do another one for the service itself, which is which is just chmod 664 etc systemd system, and then the SCP daemon service. Okay, so now we want to get this to start up when we load the server itself. So the easiest way to do that is to go to cron tab, -e, and you can see here I have put this in under our Duck DNS setup here, so at reboot space user local bin SCP startup.sh, and that will then run when the system boots. I'm now going to write and quit out of the cron tab. We're going to reboot the box, and once we're back up and online, we'll just double check that everything has started up and unlocked properly, and then we are good to go. Okay, so our box has restarted now, so we're going to log back in. And we can sudo to su, go to our mount point, and we're just going to type /spc wallet. And we can see here it's unlocked, it's showing our current balance. If we do a top, we can see SPD is running here at the top, so everything is functioning as normal. Okay, so just to finish up as well, we can go to the ScPrime site here, grafana.scpri.me, and you can actually find your node in the list. So I'm just going to do a quick filter just to make it easier. So here's the one we've just created. I'm going to click OK, and if I select this, we can see a sort of basic overview here, but we get more details if we go into the system here. So we can see status online, the uptime, accepting contracts, when it was last seen, how long the scan took. We can also see things like whether we are in compliance for incentives. So we've got green ticks on the price, collateral, capacity, and contracting, which is nice. We can see our uptime here. So while I've been playing around and turning things on and off, it's been up and down a bit. So the uptime should increase a lot over the next few days. We can also see an overview of our contract parameters. So these are what we set up via the command line. I'll also just quickly show you my other node that I've had running for a couple of months now. And this is my 5 terabyte one running on Windows. But I just wanted to show you the incentives that I've received so far. So just for being in compliance with all of the incentives, I have received 19.6 SCP last month for just being compliant. So in theory, when we get more used storage, when the system goes fully live and open, we should then get more SCP for our used capacity. They're adding the location performance in the future, I believe. But yeah, I just wanted to show you that. So that 19.6 is, well, the current price of SCP is, what, 97? So times 19.6, that's $19 last month just for having the node online. So that's quite nice, really, just to know that when you're compliant, you do get a nice amount of SCP as a reward. But anyway, I shall change over now. We're going to just have a look at my node in place just for fun, and that will finish off the video. Right, so I'm in my server room here under the stairs, and we're just going to power up the node now. So I'm just going to lie it here on top of my HP server, and that's it really. We've just created our own XA miner for a fraction of the cost, and yeah, okay, we've only got a 5 terabyte hard drive on here, but you can't really complain for the price that you've paid. You can obviously increase your price depending on how much you're willing to spend on a bigger drive and go from there, but yeah, for a 5 terabyte setup, I think it's quite nice. This is my other node here running on the back, which is actually running off a VM, a Windows VM on here, which a bit more fiddly to set up in my opinion. I did find it a lot easier to set this one up, as much as it did take a bit longer to create the metadata. But other than that, yeah, it's now set up and ready for use. Now, I know it's a bit of a mess under here. I am planning on putting a shelf over here so I can actually sort out some of this and do a bit of cable management. But for the time being, it's obviously okay where it's sat. But yeah, hopefully you enjoyed this video. If you did, please do click on the like button and be sure to subscribe. I'll be doing some updates when the system goes live fully, and we'll see how we're doing with our storage on both of these systems. Now, I do have 2 internet lines. You can run on the same internet line if you wanted to. You'd have to just change the ports, so 4282 would become something else. You can do that via the command line. But yeah, I've got 2 phone lines coming in here, so this is running on my second line, and my one at the back, which is running on the VM, is running on my sort of primary line. So that's how I've done it here. But yeah, I hope you've enjoyed this video. If you did, like I said, please do like and subscribe. Got plenty more other videos of making passive income, which I've put in the playlist at the top right of the screen. And yeah, if you have any questions or problems setting yours up, do leave a comment and I'll try and help you out as best I can. I'm not an ScPrime expert. I'm certainly not a Linux expert, but I'll do my best to help where I can. So again, thanks for watching, and I'll see you in the next video.